At this point, you should already know how to write an equation for a single replacement reaction and how to identify one. If the lone element that you're starting with is a metal, then you look for the metal in the compound and you replace it so that the metal that was in the compound is now alone. That won't always happen. We have to look to the activity series to see if that reaction is really going to happen. It's only going to occur when you have a more reactive metal replacing a less reactive metal in a compound. So here's our analogy, and I'm sorry, my mullet guy looks a bit like a dog or a cat. He's supposed to be the unattractive man with the mullet, and he is for some reason dating this pretty girl. Along comes a handsome man with a mohawk. So this would be a less active metal. This would be a more active metal. And in this case, we would get a replacement where now the more active metal is in the compound, the less active metal is not in the compound anymore. So the activity series would also tell us that if this was the reactance, if she was currently dating the more active metal and mullet man came along, that no reaction would happen here. She's not going to leave a more active metal for a less active metal. She's not going to set this guy free to be single and put him in her compound. So we're going to practice using the activity series with a couple of actual reactions. Here, aluminum is our lone metal, and the compound is sodium chloride. Well, aluminum is the metal, sodium is a metal, this is a nonmetal. So that means this will be my new lone element. Sodium would be off by itself, and then aluminum would be in a compound with chlorine, which would have to become AlCl3 because of aluminum's oxidation state of +3. Now this is the same thing as taking a piece of aluminum foil and putting it in some salt water. Do that at home. Make some salt water, take some aluminum foil and put it in there, and you should get a whole lot of nothing. And here's why. If we look at the activity series and we find aluminum, it's right here. Okay, and then we started out with aluminum. We're going to end up with sodium by itself. Well, sodium is up higher on the activity series. You would be going from taking a relatively unreactive metal and replacing it with a more active metal independently. This would not happen. You only can have a reaction going if you end up with something decreasing activity. Let's take a look at the next one where you take that same aluminum foil, but you put it in some silver nitrate solution. You guys did this in lab, but for some reason it didn't work the way it was supposed to. So aluminum is a metal, silver is a metal. That means this is going to be my new lone element. Aluminum will be in a compound with nitrate, and because of oxidation states, it needs to be a 3 right there. So then we look at the activity series and see if this is possible. We're still starting with aluminum, and this time we're going from having aluminum by itself to having silver by itself. So we find silver and it's way down here at the bottom of the activity series. We go from having an element somewhere near the top by itself to something way down here in the not reactive section. This reaction would happen, and it should have when you did the lab if my aluminum foil hadn't had something wrong with it. Now this is what I think you observed when you put the magnesium in the solutions. So even though this is not a metal, it still can become +1. And since magnesium would become +2, we are going to replace a cation with a cation. So we're going to have hydrogen displaced as our lone element, and we're going to have magnesium hydroxide as our new compound. Magnesium's oxidation state is +2, that's why we need 2 of those. So we look on the list, we find magnesium right here above aluminum, and then hydrogen is on here. It's in parentheses because it's not technically a metal. This thing at the top says metal. It's not, but because it can become +1, it can act like a metal. We would go from having magnesium alone to having hydrogen gas alone. That says that it should happen. So when you put the magnesium in the solution and you saw bubbling, I am pretty sure that this is what you witnessed. Hydrogen gas was being produced. That reaction should happen. The one that you thought was happening because you had put magnesium in a solution of magnesium chloride would give you absolutely nothing new. There is no reason a reaction would happen to go from magnesium to magnesium. That's a whole lot of effort for no gain whatsoever. So this should not have happened, but because this was dissolved in water, I believe you saw this reaction because you did go down the activity series with this.